It survived fire, pressure, and blades sharper than razors. Yet it hasn't left the factory. Before it ever touched your wallet, your credit card endured brutal flames and blades. Now it's just gotta survive your spending habits. It all begins with tiny colorless pellets, pure PVC. These plastic granules are poured into industrial hoppers, melted at over 400 degrees Fahrenheit and pressed into giant glossy sheets roughly the size of a poster. Each sheet can eventually hold dozens of cards. PVC isn't just chosen for cost, it's incredibly durable, bendable without breaking, and resistant to wear. Unlike paper or cardboard, it holds up against heat, pressure, and years of swiping. In fact, a standard credit card can survive temperatures up to 120 degrees Fahrenheit without warping. Some premium versions are PETG or recycled composites, but PVC remains the industry's backbone. What starts as shapeless plastic is about to become the face of your finances, and it's only step one. But before it can hold any value, it needs a face and a tiny little secret. Next comes the illusion of simplicity. Each sheet holding 40 to 60 cards is fed into a high-speed printer. But this isn't just about color or logos. These machines use UV reactive inks, invisible microtext, and diffraction holograms that shift under light. Every detail, from the background pattern to the fine line textures, helps stop counterfeits. What looks like simple decoration may actually hide a security code, a watermark, or a thermal trigger only machines can read. Even the front is chosen for scannability. This is designed with purpose. Art meets encryption. Some cards even feature unique overlays or foil layers based on the bank's security preferences. And once printed, the surface still needs to be sealed both for protection and for permanence. And that's because beneath the shine lies something invisible and far more important than gloss. Lamination isn't just cosmetic. After printing, each sheet is sandwiched between transparent films and pressed through heated rollers at over 250 degrees Fahrenheit. This bonds the layers into one solid temper-resistant slab. But here's where it gets smarter. Within that thin space, banks insert covert elements, metallic foils, ultraviolet watermarks, and thermochromic inks that only appear under specific light or heat. Some layers include radio-blocking films or embedded serial codes. These aren't visible to the naked eye, but they are essential in detecting fraud. And the result? A card that feels smooth but hides multiple layers of defense. It's nearly impossible to alter without destroying. Yet, for all this sophistication, the card still lacks one crucial component, the part that holds your data. I'm talking about the chip. All these aren't cards yet, they're mere sheets until the blade makes its move. So the giant laminated sheets face one of the most exacting machines in the factory, the precision cutter. Using high-speed industrial guillotines, the sheets are sliced into individual rectangles measuring exactly 85.60 by 53.98 millimeters. Now, that's not arbitrary, it is actually a standard that's used worldwide for credit cards, IDs, and driver's licenses too. Edges are trimmed with micro-level accuracy to ensure every card fits ATMs and chip readers without fail. Any miscut? Scrapped immediately. The trimmed waste doesn't go to landfills. A lot of manufacturers recycle it, and some even use up to 85% post-consumer plastic in new cards. It's clean, it's efficient, and it is precise. But next comes the step that personalizes every card. This is where it finally gets tied to you. Because this blank card means nothing until it's stamped with your identity and credentials. Once cut, each blank card moves to the embossing station. This is the machine that presses raised letters into the surface with surgical precision. Your name, card number, and expiration date are punched into the plastic letter by letter. This design wasn't always aesthetic. Originally, embossing allowed mechanical imprint machines to press the numbers onto carbon slips for processing. Today, while most payments are digital, embossing still acts as a tactile backup and fraud deterrent. To enhance readability and add a premium feel, banks apply silver or gold foil over the raised characters. It's one of the final human-facing touches, because what follows isn't just about appearance anymore. It's about data, and the next step installs its brain. But what you can't see is already storing everything that you've ever spent. On the back of every card lies a black or brown strip, and it is far more than decoration. That magnetic strip contains 3 separate data tracks embedded with iron oxide particles. Using precise bursts of electric current, machines polarize these particles into readable patterns, storing your account number, expiration, and security codes. It's primitive by today's standards, but it's still functional in millions of machines worldwide. Surprisingly, the data survives wear and tear and scratches thanks to redundant encoding and surface bonding. That's why old cards often still swipe, even when scuffed. But while the mag stripe is familiar, it's also vulnerable to cloning. That's why modern cards rely on something smarter, deep inside, soldered into plastic, and nearly impossible to fake. I'm talking about the EMV chip. All of that data is useless unless it's protected by something nearly impossible to crack. This is the brain of your credit card. At this stage, a robotic arm places a tiny microprocessor chip onto the plastic, embedding it within a millimeter of precision. It's soldered in and sealed, permanently bonded to the card. Inside the chip, 128 kilobit of secure memory, a tamper-resistant encrypted core, and a miniature contactless antenna. Unlike magnetic strips, these chips generate unique transaction codes each time they're used, making duplication virtually impossible. This shift, manufactured in a lot of countries, reduced card fraud by over 70% within 5 years. It's fast, it's secure, and it's smart. And once it's in, your card finally becomes active. But before it reaches your wallet, there's one last gate that it has to pass. And at this stage, even a single flaw means this card is never going to leave the factory. Before any card is approved for shipping, it faces an intense final screening. Automated scanners verify every detail: chip functionality, mag stripe accuracy, embossed data alignment, and even lamination thickness. If a chip fails to respond or data doesn't match the system's encryption rules, the entire card is flagged and instantly destroyed, shredded or incinerated to eliminate any trace of sensitive information. For premium or metal cards, a human inspector adds another layer of scrutiny, checking tactile feel, finish, and visual defects. This stage is not optional. One faulty card could compromise the network or customer trust. Only after surviving every test does the card qualify for shipment. But where it's going next? That's where secrecy and speed collide. And the final journey is heavily guarded because delivery is the weakest link. Once approved, each card is matched to its intended user through encrypted databases. The card and PIN are never printed or shipped together. PINs are often mailed separately or delivered via secure apps. The card itself is inserted into tamper-proof mailers or handled by armored vehicles for bulk deliveries to banks. High-volume facilities can personalize, print, and dispatch thousands of cards per hour, with some banks offering same-day issuance. For premium customers, custom packaging and express couriers are used. Each step is tracked, each destination verified. By the time it hits your mailbox, this tiny object has passed through fire, code, and steel. But its evolution doesn't stop there, because tomorrow's cards won't just store your name, they'll recognize your fingerprint. You see, the next generation of cards won't just hold data, they'll sense you. It's really crazy how credit cards are evolving so fast. The latest prototypes include built-in fingerprint sensors that verify your identity before a transaction even begins. No PIN, no signature. Some banks now issue metal hybrid cards, 3 times heavier than PVC, built with stainless steel or titanium cores. These things aren't just for show. They're more durable and harder to clone. And coming soon, dynamic CVV codes. These printed numbers on the back of your card will refresh every hour via an embedded chip, rendering stolen data useless. With each upgrade, the line between security device and payment tool blurs. What began as flat plastic is becoming a living piece of encrypted identity. You might still swipe it, but it still contains everything that you do. So which part surprised you the most? Let us know in the comments down below.